in this example, we're going to apply the newly learned formula for solving the quadratic equation to find the x-intercepts of the parabola x squared minus 4x plus 3. So what we have here is we have this parabola x squared minus 4x plus 3. So here is y equal to x squared minus 4x plus 3. So we're having this parabola. We can plot that parabola. That's already done for us. We could plot it with our graphing device. Here's the plot. And we're asked to find the x-intercepts. So what are x-intercepts? Well, the positions where the graph of our function intersects the x-axis. So just a reminder, the x-intercepts, so the places where the graph of our function intersects the x-axis, are precisely the solutions of the equation x squared minus 4x plus 3 equal to 0. So if you want to solve this equation, x squared minus 4x plus 3 equals 0, so the solutions of this equation are the x-intercepts. So asking you to find the x-intercepts of a function is just a fancy way of asking you to solve this. So find the x-intercepts, that's the same thing as asking you to solve this. Okay? So when you see a problem stated like this, find the x-intercepts, you're in fact asked to solve an equation. So we need to solve this equation, x squared minus 4x plus 3 equal to 0. That's the equation we're trying to solve. And we already saw that we have a ready-made formula. So there's nothing we need to do in order to solve that quadratic equation except apply the formula. So let's do that. Our two solutions, x1 and x2, are given by the formula minus b plus or minus radical of b squared minus 4ac divided by 2a, where b is equal to negative 4. So that b here, I have to replace it with negative 4. That's negative 4. A is equal to 1, right? So here I'm having 1 times x squared. That's what I'm having here. So A is equal to 1. A is equal to 1, right? Because once again, when I have x squared, it's the same thing as 1 times x squared. And finally, C is equal to plus 3. So that's what I'm having there. Now, minus 4 is plus 4. Minus 4 squared minus 4 times 1 times 3, what's that equal to? That is equal to minus 4 squared, that is 16. 4 times 1 times 3, that is 12. So that is 4. So I'm having radical of 16 minus 12, which is radical of 4. So I'm having radical of 4 over there. So 4 plus or minus radical of 4 over 2. Radical of 4 equals 2. So I'm getting 4 plus or minus 2 over 2. So that is 4 plus 2 over 2 or 4 minus 2 over 2. Now notice that when we have plus or minus, right, so this here is read plus or minus. This is plus or minus, right? Plus or minus. That's what we're having here. You can expand that using this curly brace. So whenever you have a plus or a minus, you can expand it into a curly brace, and then in one of the entries of the curly brace, you enter the plus, and in the other entry of the curly brace, you enter a minus. So that curly brace is just a different way of saying plus or minus, or one line or the other line. Okay? Now, 4 plus 2 is 6, and 6 divided by 2 is 3. So that's one of our solutions. Now 4 minus 2 is 2, and 2 divided by 2 is 1. So that's another solution. So here are our two solutions, 3 and 1. That solves our problem. So we have found the x-intercepts of our quadratic. So here's the number x equals 1. here's the number that would be x1, and here's the number x2. Okay, x2 would be equal to 3. We have solved our quadratic equation using the quadratic formula. This example is very similar to the previous one. In the previous example, I asked you to find the x-intercept of a quadratic function, and in this example, we have the exact same formulation. Find the x-intercept of the quadratic x squared over 2 minus x minus 1. So find the x-intercepts of that quadratic, or in other words, solve the equation x squared over 2 minus x minus 1 equal to 0. Now you're going to say, well, why am I making you solve very similar problem types one after the other? Well, there's going to be a small difference between this problem and in the previous one. So what's the first difference that strikes us? Actually, more than one difference. There will be more than one difference. They're not going to be big, but there will be differences. So what's the first difference that we see? Well, we notice that here the coefficient of x squared is 1/2, right? So I'm having x squared over 2, but see, x squared over 2, that is the same thing as, x squared over 2, that is the same thing as 1/2 times x squared. So I can rewrite x squared over 2 minus x minus 1, I can rewrite it as 1/2 x squared minus x minus 1. Okay, so that's how I can start. So that's the first small difference, that the coefficients of this quadratic are a little bit masked due to the division operation, but that's just a tiny difference. That's nothing significant. Okay. Once again, in this problem, we are ready to directly apply the quadratic formula. So we don't need to think much. Once again, we can directly say, well, the x-intercepts are simply given by the formula minus b plus or minus radical of b squared minus 4ac divided by 2a. Okay. What's b equal to? Well, b is equal to -1, right? Because here I'm having negative x, and negative x is the same thing as -1 times x. So b is equal to -1. b is equal to -1. Right, so the coefficient of x here is -1. What's a equal to? Well, a is equal to 1/2. So a is equal to 1/2, right? Because I'm having here x squared over 2, which is 1/2 times x squared. So a is 1/2. A is 1/2. Right, that's that 1/2. And what's c equal to? Well, that's easy. C is equal to -1. Okay, so we're done with the formula. That was the whole thing. So let's simplify. The 2's cancel. -1 is equal to +1. And what happens here? Well, let's see. We're having -1 squared minus 4 times 1/2 times -1, which equals, well, -1 squared, that is equal to 1. 4 divided by 2, that equals 2. So I'm getting -2. Here I'm having 1 minus, here I'm having a second minus. So 1 minus -2, and 1 minus -2 is equal to 3. So that whole expression that we see here, that whole nasty expression, is equal to 3. I just simplified it here for you. Okay, so that expression is equal to 3. Well, that's it. We're done. Our two solutions are 1 plus or minus radical of 3. Right? So here's 1 minus radical of 3. And here's 1 plus radical of 3. Okay? There's a small typo on the slide. Please ignore that. Once again, this is 1 minus radical of 3, and this is 1 plus radical of 3. I promised you that there were tiny differences between this slide and the preceding one. Well, The number one difference was that here somehow the coefficient in front of x squared was masked. So the most remarkable difference from the beginning was that the coefficient in front of x squared was rather hidden, and you could now see this second very small difference is that, well, in the preceding example we were lucky to get a perfect square under the radical. So in the preceding example we were able to simplify the radical that we were getting. So in the preceding example the term which corresponds to this term here was, we were able to simplify it in addition, right? So in the preceding example we had radical of 4. In this example we have radical of 3. That we cannot easily simplify. So that's the major difference. Okay. And here's our final solution. In this example, we're going to do our last basic application of the quadratic formula. Again, we have a problem formulated the exact same way. Find the x-intercepts of x squared minus 2x plus 3. So here's the quadratic x squared minus 2x plus 3, and we're being asked to find its x-intercepts. Just a reminder, the x-intercepts of a function correspond to the place where its graph intersects the x-axis, and to find the x-intercepts of a function means to set the function equal to 0 and to solve the equation. So I'm asking you to solve x squared minus 2x plus 3 equals 0. Now, if you plot x squared minus 2x plus 3, if you plot it, it's going to look like this. This is an accurate plot. And this is a parabola. We already studied that that's the vertex of the parabola is its lowest point. So we expect from the graph, we expect that there will be no real solutions. We do not see any intersections of the graph of that function with the x-axis, so we expect to see no real solutions. Well, let's see if that is the case. We know that the x-intercepts, so the solutions of our quadratic equation, are found by the formula minus b plus or minus radical of b squared minus 4ac divided by 2a. What's b equal to? Well, b is equal to negative 2. That is our b. Careful here, this minus has got to stay in front of the parentheses. So b is negative 2. A is equal to 1, right? Because we're having x squared, which is 1 times x squared. And then a is equal to 1. A is equal to 1. And finally, we have that c is equal to 3. C is equal to 3. So we're done. We have applied our formula, and that's it. Minus 2 simplifies to plus 2. And what happens with that expression? Well, we have minus 2 squared minus 4 times 1 times 3, which equals, well, minus 2 squared, that is 4, and 4 times 1 times 3, that is 12. So 4 minus 12, which equals negative 8. So that expression that we see in here equals negative 8. And of course, 2 times 1 equals 2. So that's it. We're done. Now, radical of negative 8, that is not a real number. So we have no real solutions. So for no real number, does the graph of our function intersect the x-axis? So no real solutions, no x-intercepts. So our final answer should be no x-intercepts. So we're asked to find the x-intercepts, but our answer is too bad. No such intercepts. Our problem is solved.